Hello and welcome. I'm Dr. Matthew Rasmussen, and in this series of slides I'm going to describe the important aspects of a correlation. A correlation is so important to learn, and if you haven't learned it in a prior psychology class, this will be a great introduction to it, and also possibly a review. So what is a correlation? Well, here's a great example. I found this on the Yahoo website in about 2009. Don't worry, I don't get all my news from Yahoo. I just happened to find it, and it's a great example. So gaming is linked to depression, it says. A new study finds that the average gamer is overweight, shy, and mentally depressed. So this is a correlation. A correlation, in other words, is an association between two variables. What are these two variables here? First variable is gaming, and the second variable is depression. There is an association, meaning that as one increases, the other changes. That may increase or decrease. In this situation, it looks as though as the amount of video games an individual plays, the amount of depression that an individual experiences increases. The researchers even go on to find that gaming is also linked to overweight as well as shyness, so an individual's weight as well as their ability to interact in a social situation. Again, other correlations. Okay, so perfect example of a correlation, and a correlation is essentially a relationship between two variables, or you can say a relationship between two factors. Once you know a value of one variable, it will essentially allow you to estimate the value of a second variable. So once a correlation is established, you will be able to determine a value based on another value. That is the benefit of a correlation. So essentially, to kind of wrap this together, is as one variable changes, so does the other. Okay? So as one variable, as the first variable changes and increases, the other variable will also change in direct response to that variable. And it will change in a somewhat predictable manner. So here is another correlation. Soft drinks linked to aggression in kids. So this is a correlation, again, because there is an association between two variables. And that association includes soft drink consumption and aggression. So as one increases, the other will increase. So as soft drink consumption increases, so does aggression. Well, in a correlation, you can also look at it the opposite way, in that as aggression levels increase in a child, so does soft drink consumption. And this is an example of a positive correlation. Okay. We're also going to describe what a negative correlation is in just a moment. But positive and negative in respect to a correlation, that means the direction of the variables. Okay? And don't think that positive means good and negative means bad. There is no way that that means that. Okay? So positive means one thing and negative means the other, and I'm going to describe positive right now. So positive correlation is a correlation that has the correlation coefficients, and the correlation coefficients we're going to discuss in a few slides, so don't get worried if you don't understand that now, but for those who this is a review for, this is benefit right here, in that it ranges from the minimum is 0.1 to essentially +1, which is a perfect correlation, and that is a correlation coefficient, and we'll describe that in the next series of slides in a few. So what a positive correlation is that when both factors increase, as demonstrated with those two arrows, is that they both increase or that they both decrease. And both increasing or both decreasing, that is a positive correlation. So when two factors increase at a similar time, or when you basically say the opposite, they can both decrease at the same time, and that is a positive correlation. So here's a great example. Studying time and score on a test. So if you ever knew an individual who studied a long period of time, they're likely going to do pretty well. Versus your friend who studies very, very little, well, they're probably going to do pretty poorly. And that is an example of a correlation. So let's map this out with an XY axis. An XY axis, as demonstrated here on the x-axis, which is the lower one, that is the test score, ranging from, it has range of 100, minimum 0, maximum 100. On the y-axis, we have the amount of time an individual studies per week, the minimum 0, and then the maximum 12. And what you see is that as people increase in their amount of test score, as demonstrated here, they have a dot in this side of the x-axis, well, they're also a little typically higher than those individuals who get a poor test score, meaning that as an individual increases their studying time, they also increase their test score. Or conversely, as an individual increases their test score, they also increase in studying time. So let me pull out a couple dots here. This individual studied for about 10 hours and they received a 90 on the test. And this individual only studied for an hour and they received a 30% on the test. And as you see, if you were to draw a line through these variables, just one that is about the average, it would be tending to increase in such a manner, something along those lines. And that is a positive correlation. The variable 1 increases as variable 2 also increases. So as studying time increases, score on a test increases. Or you could say the opposite. As score on a test decreases, as you go down here, the amount of studying time also decreases, as demonstrated here. Okay? So negative correlation, that's one. A negative correlation can be represented with the correlation coefficients of a maximum of -1 to just around 0, which would be about -0.1. But again, that's a correlation coefficient, and we'll describe that in just a moment. Now, a very excellent way to describe what a negative correlation is that as one factor increases, the other factor decreases. Or you could say it oppositely, in that as one factor decreases, the other factor increases. So again, as one factor goes up, the other factor goes down, or as one factor goes down, the other factor goes up. This is essentially the definition of a negative correlation, in that these two variables are incongruent. As one goes up, the other goes down, or vice versa. Here's a great example. Video games played and score on a test. So you can conceptualize that as you play more video games, you're probably going to do poor on a test. We're not talking about a test here in respect of video games, like a test on Mario Brothers or something along those lines. We're talking about a test in respect to school. So as you play more video games at home, you're probably going to do poor on a test. And here is an XY axis. On the X, you have the test score, a range of 100, minimum 0, maximum 100. You have the amount of time an individual plays video games, a range of 12, minimum of 0, and maximum of 12 hours. And as you see on the x-axis, you have individuals who perform better, meaning that the dots appear on this side of the x-axis, meaning that they get a better test score. We also see that those dots are lower, suggesting and actually stating that they played less amounts of video games that week. These individuals who did poor on their test, as represented here, well, those individuals played more video games. Of course, you have a couple of individuals here who just did poor just by nature, but essentially these people who did poorly, they played more amounts of video games per week than these individuals who did better. So let's just pick out a couple dots at random here. This individual played for about 10 hours, and the individual received a 30% on their test. This individual played for nearly 3 hours and received about a 90% on the test. So again, if you were going to draw some sort of average between these lines, it would probably be somewhere along the lines of here, and that would be a negative correlation, in that as one factor increases, the other factor decreases. So just to give another example of something that could happen in life is, well, what is the actual relationship between television exposure and aggression? Well, you could have three different possibilities. There could be a positive relationship, as the amount of hours an individual watches of TV per week increases, the number of aggressive acts also increases. You could have a negative correlation, as one factor increases, such as the amount of TV watched per week increases, the number of aggressive acts decreases. Or you could have no relationship at all, whereas one increases, the other doesn't do anything. It just stays about the same. So essentially here we don't have any idea what one factor would be based on the other. And what we have here is we have three correlation coefficients as marked in these three boxes. We have a plus 0.6, we have a negative 0.6, and we have a correlation coefficient of 0. And what this demonstrates is these various numbers. This demonstrates the strength of a correlation, essentially the strength of how these two variables are associated with one another. And that is what a correlation coefficient does. It represents the strength at which a correlation represents. Now, the strength of a correlation means that these two variables are better associated. So the stronger a correlation, the higher the correlation coefficient. Well correlated, okay? And the strength of a correlation ranges from -1 to potentially +1. Now, researchers essentially come to an agreement on what the strength of a correlation means, but researchers have not come to an agreement on what the cutoffs are for a perfect correlation. Everyone agrees that a perfect correlation is one where it's a perfect one, either a perfect +1 or a perfect -1, meaning that if one variable increases, the other variable will decrease in the same exact manner. So if you know the variable, the first variable, you are guaranteed to know the level of the second variable. Okay, that's also called a one-to-one correlation, a perfect correlation. A strong correlation, the minimum could be about 0.7 to about 0.9. That is, again, either positive or negative. A moderate is 0.4 to 0.6, and that is, again, either positive or negative. A weak correlation is 0.1 to about 0.3, and that, again, positive or negative. And then a zero correlation people have agreed on, and that is where you have the correlation coefficient of nearly 0, 0.01, something along those lines, 0.001, something along those lines, where it's very, very minimal, and that is where one factor increases. You have no idea what is going on with the other factor. It could be decreasing, increasing, there's just no rhyme and reason. So again, this represents the strength, and as you increase in correlation coefficient, it is a stronger correlation to where you reach the pinnacle, and that is a perfect correlation. If you know one variable, you're going to know the other variable for certain. Here's a wonderful picture of the scatter plots on the XY axis of a negative correlation, a negative perfect correlation to a positive perfect correlation. And you can see, if you start up in this left-hand corner, it's a -1 correlation going down to a strong, to a moderate, and then to a weak. Is that these dots are becoming more congruent. They are becoming tighter spaced. Tighter spaced is a great word to use, in that they're becoming more predictable. As you have one value on the x-axis, you're going to know essentially the value on the y-axis. Okay. However, if you look at a correlation coefficient of 0.2, if you know one value on the x-axis, it's kind of difficult to know the value on the y-axis. Same goes for here. If you know one value on the x, it's again kind of difficult to know the value on the y, but it becomes a little bit better with 0.5, and it becomes very, very good with 0.9. You know one value on the x, you're pretty good to go on the y value. But here again, the perfect correlation, if you know one value on the x, you're going to know exactly the value on the y. Okay? So again, the great representation of negative correlation as well as a positive correlation. Negative, the variables are decreasing as one increases, whereas positive correlation, both factors increase at the same time, or both factors decrease at the same time. So let's revisit this correlation between television exposure and aggression. Well, we said that this could either be a positive relationship, a negative relationship, or no relationship at all. So what is it in reality? Well, some researchers have agreed that there is a positive correlation. Some of the researchers have found that there's quite a large positive correlation between the amount of TV an individual watches versus the aggression that they commit, so the aggressive acts that they commit. Researchers have found that as individuals increase the amount of television, they get into trouble with the law more, they're a little bit more aggressive. But there is also some research that has found the opposite. But nonetheless, there is a pretty well established positive correlation between television and aggression. So does this positive correlation allow an individual to determine cause? Well, let's investigate that question. So do correlations inform an individual about causation? And that answer is no, absolutely not. If you have a correlation, that does not mean that cause is in accord. And the reason that correlations don't inform an individual of cause is that variable A could have caused variable B, meaning that exposure to violent media increases levels of aggression, and that's what you would want to expect, is that as you watch more television, the individual is going to become more aggressive. Could also be, however, that B could in fact cause A. That as aggression increases, exposure to violent media or television also increase. So you don't necessarily know if it's A causes B or B causes A. It could be the opposite, that something else is causing both A and B to increase. That could be factor C. Some outside variable is causing factor A to increase as well as factor B. What could that outside factor be? That could be bad parenting. Okay? Bad parenting causes children or adults to watch more TV, and that is also not even related to bad TV or TV. That child or that adult is just going to become aggressive by nature from that bad parenting. So you don't know if A causes B, B causes A, or C causes A and B. That is impossible to determine from a correlation. A correlation only suggests that there is a relationship between two variables. It doesn't tell you which one started and then finished. So here is essentially a great description on how correlation does not equal causation. And correlation does not equal causation, that's a great term to take away from Intro to Psychology. An example, time practice equals a score on a test. Again, there's three possible interpretations. These three possible interpretations is that the first one, A caused B, practicing causes good test scores, and that's likely, A causes B, but it could be that B caused A. Good test scores increase practicing, right? Those kids are just going to perform well on a test. They're automatically going to practice. They're automatically going to study. And you know what? That studying doesn't even do anything. They just automatically study. It could be a third variable in that smart people practice, but that smart person, they're also going to get good test scores. And practicing doesn't have any cause on good test scores. Basically, that third variable, the outside variable, just intelligence. A smart person, well, they're going to practice, and that smart person, well, they're just going to automatically get good test scores. So we don't know which came first. Very, very difficult to determine in a correlational experiment. So here's really to drive home this fact that correlation does not determine causation. Here's a great example. As ice cream sales increase, so do crime rates. Wow, right? Let's ban all ice cream sales. And this is supported with research that as ice cream sales increase, so do crime rates. So we would like to ban ice cream sales, right? Well, no. What's going on here? Well, it's likely a third variable. What would that third variable be? Think about it for a moment. You can pause it. That third variable is heat. As it becomes hotter out, the temperature increases, well, people are going to buy more ice cream. As temperature increases, crime rates increase as well. It doesn't take a rocket scientist to figure out that criminals aren't going to be robbing people, mugging people, breaking into cars when it's very, very cold out, right? But what are they going to do? Well, they're going to likely come out more in the summertime. Maybe they're going to be a little more aggressive because it's hot out, things along those lines. That's what's making the crime rates increase. So again, temperature is the third variable that's actually causing this relationship here. Another relationship. The smarter a person gets, the more likely they are to die. Wow, right? Let's just all become dumb um, and then we'll be less likely to die. Well, again, there's no cause here in that as the smarter a person gets, the more likely they are to die. But what could be this third variable? That's age. As a person gets older, they're likely to get smarter, at least in the amount of words that they know. Maybe, they become an expert in their field. And then they're also more likely to die. Okay, because they're also older. An older individual is more likely to die. So again, that third variable here is age, and that's what's causing A to increase as well as B to increase. And the final one is as boys develop facial hair, the deeper their voice becomes. Wow, so facial hair is actually making a voice become deeper. That's just flabbergasting, right? Again, facial hair doesn't make a voice deeper, right? Those two things just happen to increase at the same time, and that's because of puberty. So puberty is actually causing facial hair to appear as well as the deepening in the voice. So again, we have three great examples here that really drive home the fact that correlation does not equal causation. Here are some wonderful real-world examples. So in other slides I've discussed the relationship between the MMR vaccine, which is the measles, mumps, and rubella vaccine, and the development of the developmental disorder, autism. So in the real world, people have exposed their children to the measles, mumps, and rubella vaccine, and then they subsequently, the parents assume that the child develops autism. And they see a correlation here in time that when they receive the vaccine, these children also develop autism. Well, the third variable that could be causing the MMR vaccine to increase as well as the autism to increase could be age. Okay, in that the older a child gets, around the ages of 2, the more likely they are to receive the vaccine, and then subsequently, the older the child gets, the more likely the developmental disorder autism is to be seen in a child. So it's not quite often that autism is diagnosed at the very, very early ages of infancy, but it's more along the lines of about the age of 1 to 2 to possibly 3. And again, what is that? Well, that's the exact same time that they're getting the measles, mumps, and rubella vaccine. Measles, mumps, and rubella vaccine, very essentially no evidence that that causes autism. But it's just a mere correlation. Correlation, third variable. Third variable influence is age. So again, that third variable C there is age, and that is causing an individual to get the measles, mumps, and rubella vaccine. But that age, as the age increases in the child, that is also causing the individual to start expressing those tendencies to have autism. Okay. So, an illusionary correlation. Illusory correlation is another key word that's important to take away from this whole introductory to psychology, this whole correlation talk. Okay, and illusionary correlation is when there is a perceived relationship, however, nothing exists. Okay, so you perceive there to be a relationship, but actually in reality, there's not one. Or the relationship is perceived to be stronger than what it is in reality. So let's pretend that there's a very, very weak correlation in reality. People think that it's a really, really strong relationship in reality. So this is what an illusory correlation is. So why does this occur? Why do people fall victim to an illusory correlation? And I'll give some examples in a moment. Well, for one reason, people see illusory correlations very easily is because we are essentially predisposed, or we take this from a very, very early age, that we see cause in some sort of relationship. We essentially see cause very, very easily in relations. So we see cause and effect very, very easily. So here's an example. You tell everyone how your team is awesome, right? You're playing on a sports team. You're like, man, my team is awesome. We kick butt. We're going to win. We are the best. I'm playing great. The goalkeeper's playing great. But then you lose, right? What do you then blame that loss on? Do you blame it on you guys playing poorly? No, of course not. You blame it on the fact that you said you were awesome. You basically jinxed yourself. Okay? So if you have ever had that come about in a situation where you believe you jinxed yourself, something along those lines, or you jinxed your team, your sports team that plays on TV, well, that's you seeing a relationship between the cause that you thought it was, you speaking about that team, and the effect of the loss. And in reality, do you think that that's exactly what happened? No. There's no evidence that putting a jinx on someone else that they don't even know about it can, in fact, decrease performance. So that is a great example on how we see cause and effect in nearly almost everything that we do. So here's an example of an illusory correlation. Anton holds the belief that people in the suburbs are boring. Therefore, when he meets Ronald, who grew up in the suburbs, Anton immediately perceives him as being lame. Okay? And that can be the fact, and that as you have this illusory correlation between the suburbs and lameness, okay, people who live in the suburbs are boring, you tend to see the world through that relationship. When in fact, we know that people in the suburbs are not all lame. There's a couple cool people out there. No, of course not. I mean, there are just as equally the number of cool people in the suburbs as there likely are in the city. But if someone holds that belief, they think that that relationship is much stronger than it is, and then they start seeing the world as though this matches. So they start perceiving people who grew up in the suburbs as boring. Here's another example. Every time I use my plastic Bears mug, they win. Again, this is an illusory correlation because there is likely no chance that my plastic mug is making the Bears win. Okay? And if you are a fan of the Chicago Bears, you'll know that their record is, right now, pretty poor. Okay? It's about middle of the road. Okay? And that they win some and they lose some. They're about nearly 500. Okay? I am making this correlation larger than what I think it is, okay? In that every time I use my plastic mug, the Bears win. Well, it's likely that if I was to use my Bears mug every single game during a season, that again, that Bears mug would be at nearly 500%. But I'm possibly only looking at it a couple times, right? Oh, I've used my Bears mug a couple times, and by chance, those 2 games that I used my Bears mug, they won. Okay? That's an illusory correlation. In that, in reality, if you were to look at this over a long run, you'd probably have a very, very low percent where you use your Bears mug and they also win. Okay? And so if you have any sort of lucky items in the world that you have that you need to use before your game or before your team plays on TV, well, that's an illusory correlation in that there is likely very, very little relationship between you using it, you wearing it, you saying it, and your team actually performing well. Perfect example is when individuals such as Nomar Garciaparra, the individual who played for many sports teams in the Professional Baseball League. And what Nomar Garciaparra did is before every at-bat, he had a huge routine of fixing his gloves, to fixing the bat, to taking a step off the plate, and messing with many things in regard to his hands, his wrists, as well as the placement of his hands on the bat. And if you know about Nomar Garciaparra, if you are a Red Sox fan, or if you're a Cubs fan, or even a Dodgers fan, you'll know exactly what is being described here. And what likely occurred to make Nomar Garciaparra get this huge routine is that possibly during a bat an at-bat early in his career, he may have adjusted his glove a little bit, okay? And then what did he do? Well, he got a base hit. So he said to himself, wow, that's great. I adjusted my glove a little bit and I got a base hit. Well, I'm going to do this every time I adjust my, I go to bat. I'm going to adjust my glove. And he continues doing it and continues doing it. And next time he even adjusts his wrist guard a little bit. And wow, what happened? He hit a home run. Boom. Okay, so now he incorporates that into it. When adjusting his glove, that was just a mere chance that he adjusted his glove and he got a hit. It was a mere chance that he adjusted his little wrist guard or his sweatband and he got a home run. That was just an illusory correlation, but now he's incorporating it into his repertoire. He's doing this before every at-bat. Hockey players do this. Soccer stars do this. Every athlete in every sport, at least, not every athlete, but athletes in every sport, they have some sort of routine, some sort of lucky agent that they have, or some sort of lucky theme that they do, that they commit prior to a game or even during a game to help them perform. And this is an illusory correlation. This does not mean that they are going to be better, but they believe it is going to make them better. So just to wrap things up with a correlation, is that a correlation is showing the relationship between two variables. This relationship can either be positive or negative, as we already discussed, and positive is that those two variables are congruent, whereas negative is that they are incongruent. Congruent means that as positive, both factors increase or decrease. Negative is that they're incongruent, one increases, the other decreases, or as one decreases, the other increases. The correlation coefficient is the number, it's represented numerically, and that is telling you the strength of a relationship. And the minimum is 0, and the maximum can either be a positive 1 or negative 1. It's absolutely essential that an individual knows for a fact that correlation does not determine cause and effect. So correlation does not equal causation is a great term to put in your little memory bank of what a correlation is. And the reason for that is that there's 3 different interpretations. A causes B, B causes A, or C causes A and B. An illusory correlation, what we just covered, is a perceived relation when none exists or when there is a very, very minimal correlation between two variables. And that's an illusory correlation as described on the last slide. So this wraps up what a correlation is, also wraps up what a correlation is not, and just always remember that correlation does not equal causation. Alright, I hope this helps, and thanks a lot.